Hi guys. Hi guys. My name is Harshad Patil. I'm from Findora. I work in Findora as a lead blockchain engineer. So I hope you all of you had lunch and feeling energetic. So this talk is going to be about how can you leverage the zero knowledge proof based transactions on Findora to send completely private transfers from one EVM address to another. So, getting on. So, let's begin with Findora network. So, what's Findora? So, Findora is a privacy focused blockchain and it works on similar principles as Zcash, you can say. I don't know how many of you are aware with Zcash, have used Zcash wallets or Monero. So, yeah, some of you. So, Findora is a UTXO chain primarily, and it's a proof of stake chain. So everything regarding to staking and the the main retrieval funds happens on the UTXO chain. And in the UTXO chains, you have an option to create assets and convert them to anonymous assets. And those anonymous assets can be transferred completely privately to anyone. They could be held. The proof of their ownership can be produced. So how does it compare with Monero and Zcash? So both are single asset UTXO chains. So in Findora, the UTXO have an extra parameter called the asset ID. So you can create custom assets, like you create, say, ERC20 tokens on any EVM compatible chains. And the fees are also private for anonymous transactions. That's the main difference with Zcash. So Findora, the UTXO chain of Findora can be leveraged to create and send assets, UTXOs privately, anonymously, and also hold the assets in the anonymous domain. Apart from that, what's different for Findora is that we have EVM integration. Quite like Near protocol, we have a parallel EVM running on Findora. So you can send both EVM transactions and Findora UTXO transactions. And there is something called Prism, which means like it's an internal bridge which can be used to convert assets from the UTXO domain to the EVM domain and vice versa. And we are currently working on something called Findora X, which is like giving you the complete power to send zero knowledge proofs and verify them on the EVM chain. Currently, it's like work in progress, but we soon developed and launched. So I'll show an example of Findora wallet. So this is my Findora wallet, and currently I don't have. It's a reinitialized wallet. I don't have any assets here, but there's this FRA asset I could have, and there is this Prism interface in the wallet where you can convert between your EVM address and your Findora native wallet any amounts. And this could be done also for different kinds of tokens or custom assets. So coming back, yeah. So the base of Findora is Noah. Noah is our cryptographic library full of various tools we use in the Findora blockchain. For example, we have ED25519 SCCP key implementations in Rust. We use ArcWorks cryptography libraries a lot in this. This is only for curve calculation and stuff. Then TurboPlonk implementation is done in this library. Then there is a custom constraint system we defined, which is compatible with what we call R1CS which is kind of the standard for defining zero knowledge constraint systems, and our complete anonymous transfer implementation. So converting uh, non-private assets to the anonymous domain and sending anonymous transactions and converting them back. Everything has been implemented this here. So you can go check it out on GitHub. So today for this hackathon, what I'll be explaining more would be the privacy routing SDK. A privacy routing SDK is it's a JavaScript SDK which enables you to transfer assets like Findora coin or any other FRC20 token, which is the same as the ERC20 interface format. You can send them those transactions, those assets from the EVM, from any EVM address A to address B privately. And in between, there would be the privacy and conversion transactions used in Findora. So, of course, this JavaScript SDK you can integrate it anywhere with web-based dApps like React.js or Next.js or anything you use. Also, you could build privacy use cases like private DAO salaries. So you don't have to expose your addresses while collecting DAO grants, and those can be done anonymously. Also, you can deposit or withdraw from DeFi app or bridges. So it adds a layer of privacy onto the EVM. So it's not completely straightforward, a single transaction from sender one to receiver. So what happens, as you can see in this diagram, is you have the asset in the EVM, and it is converted through Prism to the Findora UTXO chain, and from that it is converted to the anonymous domain. So this is very similar to the Zcash shielded transactions. The main difference being that the conversion can happen for any custom asset. Then from the anonymous domain, you send this to another Findora address, which is not linked to the first address. So the link breaks when you do this bar to A bar and A bar to bar transactions. So in between, there's this private domain which holds the assets. Then from the Findora UTXO domain, you can convert the asset to the EVM chain. So a usual flow goes like this: you create intermediate keys holding the assets. Then you transfer from EVM to UTXO, then UTXO to anonymous. Then again from anonymous to a new UTXO address, and from UTXO to the EVM address. So this is actually about the implementation. So for the setup, you need to install this package. It's available on npm, and there is a Findora wasm, which is used to build anonymous and UTXO transactions, which you need to download and integrate in your project. And in the project file, you need to initialize it with the correct RPC URL for the EVM. So this is the Forge testnet EVM RPC URL. So that's all about the setup. You need to get started. Then we come to the Findora Forge testnet. So this testnet has all the features available you need to use with the privacy routing SDK. There's a faucet running on a Discord group Discord channel called testnet faucet on Findora Discord server, and you can type this command with your address, and you can receive Findora tokens in the on the EVM. Then there's also there's also this website running. You can use it to get Findora and ZK USDT tokens. I'll just show you the faucet. Yeah, so you can add your EVM wallet address here and receive the token on the Findora EVM. Then for the actual wallet connect and all that stuff, like your browser stuff, you'll have to use the network config. The network config defined here. So it has the RPC URL, the Findora token chain ID, chain name, and all the currency elements. So this for that. Then yeah, you need to use it with MetaMask or any other wallet. You need to register the network, the Findora Forge network name, with the correct RPC URL chain ID. And there's also a block explorer for you to debug any transactions transfers. So as I had said earlier, so there's a simple way to create the intermediate wallets, and of course to keep them anonymous. And the second step becomes the transfer of the transfer from the EVM to the UTXO chain, and there are some differences in the way you transfer the FRA token or the way you transfer the FRC20 token. Then these are the intermediate EVM, anonymous domain transactions, the bar to A bar and the A bar to bar. I'll just skim this over fast. There's a link I can give you for the privacy routing SDK and its implementation later. And finally, when the link is broken, you can send it to the receiver EVM address. So destination address would be of anyone who's going to receive the original assets. So as I said, there's a privacy routing SDK example implemented, and you can check it out. And the good thing is there's a independent like React component. You can use this, make changes to this according to your project. And actually, I'm running an implementation of that locally. Yeah, this one. So this is how this project looks like. So internally, it has this privacy routing SDK of whatever I told, like this React component implemented, and it has all those 5 steps to make the transfer from EVM address A to EVM address B. And here you can see I have connected my MetaMask wallet, and I'm using the Findora EVM Forge testnet, and I'm from account 1, which has 1000 FRA, I'm trying to send it to account 2, which does not have any FRA. So I'll just paste this address of account 2 here, and account 1 is connected. And start transfer, and this will do all the transactions in the JavaScript behind the scenes. Yeah, so it goes on. So you can check it out, this project on GitHub. Now, if you're doing things on the server side, you can also use privacy. Needs this, I think, another. It was just asking the gas confirmation. So yeah, coming back. So if you're doing things on the Node.js side, you can't, of course, use the web browser version of the privacy routing SDK. So there's this privacy routing script. There's this privacy routing script. Uh, you can use this for your Node.js or backend.js projects. So this is about the whole usage and how it functions. So coming back, one of the questions often asked is right now which ERC20 coins are supported to be converted from like the EVM to the UTXO domain. So you can check it out. On the faucet, you can see the Findora and ZK USDT. So ZK USDT is like a bridge asset on the first testnet. So you can mint this. So it's a ERC20 token, and you can use it to transfer privately. So this is still going on. So you just need to put your address here, and you can. So it needs Discord sign in, but you can mint your ZK USDT tokens there for your MetaMask address. And other question: can we transfer directly from EVM to anonymous? So yeah, right now that is not implemented. It's in progress. So right now you have to go through the multiple layer transactions of converting from EVM to UTXO to anonymous. And if you have any questions regarding to the implementation or you're getting stuck, then you can ask us on the Findora Discord dev chat channel. And also there is a page. There's a page for this event running on the Findora website for the Eat Denver hackathon. You can check it out. It has lots of like use cases and helpful links. And so I hope like this helps to build you some interesting privacy use cases on Findora for your dApps. Thank you. I think I'll wrap it up. Thanks.